Okay, so I'm going to perform an experiment which is a simple pendulum in your manual. This experiment is really simple. So this experiment, all you need is a string, and the string we are going to change the length, so we need a very long string, and we need one bob here. If you want to work at home, you can use anything instead of this bob. For example, a small tiny ball or a bead or a small screw knot, and attach that stuff with the string, and all you have to do is attach somewhere here with the fixed length, and we are going to oscillate it. And we are going to measure how long it takes to oscillate for each cycle, but we are not measuring the time for one cycle. So what we'll do, we will make for 10 cycle or 20 cycle. So for that we need a stopwatch. So I'm going to use this stopwatch in the lab, but you can use your cell phone or anything that has stopwatch. All right, so let's get started here. Now I have here bob here, and the equation we have here is when I oscillate this, how long is the time for one oscillation? One oscillation means starting from here, it goes to the other end and comes back. So that's the one cycle. So that's called the time period T. So I have written here in the board, T is the time period, and time period is equal to 2 pi, pi is a constant, 3.14, and square root of L divided by G. L is the length of the pendulum. So length of the pendulum starting from here to the center of the bob. So if you measure distance from here to here, which is the length of the string, you have to add how much is the radius of the bob. So let's do that first. So in your data sheet, we need to measure the mass of the bob. Actually, mass of the bob is independent here. So if you want, you can measure it. Or actually we don't need that. And diameter of the bob. So diameter of the bob, I'm going to roughly estimate using this. So this is something like 3.5 centimeter. So let's write, you have to write down diameter of the bob is 3.5, and then radius of the bob is half of that. So that radius we have to add here in the length of the pendulum. So this is length of the string plus the radius, that's the length of the pendulum. And we have here different length, 0.3, 0.4, 0.5, 0.6 and so on. These are all in meter. So I'm going to adjust the length first. So length here is, this is now 30 centimeter. So I can adjust a little bit here. So it is okay, now it is set for 30 centimeter. 30 centimeter. And I'm going to oscillate this. So when we oscillate, it should just oscillate in one plane. It should not go like this. And it should not also rotate. So in order to do that, just swing simply, giving small push and let it go for a while. Then it will stabilize. So because the time doesn't matter, time will not change with that way. So once it starts oscillation, I'm going to start the counting the time. So I think it's starting to oscillate. So let's do that. I need something here. Okay, so I'm going to start from this side. So it works with stop, and then we will record the time and reset again and start again. And I'm going to count for 10 oscillation. So start 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the time here is 11 second. 11 second. So 11 second time goes here for the length 0.3 meter. Okay, then reset this, and I will set for another one. So next one is 0.4. So 0.4. Point 4 is 0.4 is here. All right, so this is for 0.4. I'm going to oscillate again. So angle has to be small, so something like this. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 12.98. 12.98 second. That's for the 10 oscillation, and you have to calculate for one oscillation by dividing 10. So let's do for 0.5. Okay, this is for reset again, 0.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 14.57 second, 14.5 second, 14.57. So let's continue for a different length. Now this is too long, so I have to put this out here, and let's rotate this. So my now length is 0.6. Okay, I set for 0.6, 60 centimeter. Again, reset this and oscillate first. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 15